Hello, and welcome to the second chemistry video in the Cell Educational series. Today we're going to be discussing the parts of an atom. Now, we will be covering moles and periodic table in our future videos. So far, I'm thinking that the next video we do is probably going to be the periodic table, and then the one after that will be the moles. Just because to understand what a mole is, I think you should know all the parts of an element and how to find them on a periodic table. Alright, so now let's go ahead and discuss what the parts of an individual atom are. So let's start with something simple, sodium. So by looking on the periodic table, which is something you'll learn to do in the next video, you'll figure out how to tell that sodium has 11 protons. And that would be its atomic number, and you'd find that in the periodic table. So if sodium has 11 protons, let's figure out what a proton is. So a proton, given by its root word pro, means positive. So it's a positively charged particle. And if it has 11 protons, then that means it has 11 electrons. Because our electrons have a negative charge. And we always want the charge on our atoms to be 0. So if we have 11 protons, then that means we have 11 electrons. So let's figure out what a proton and an electron are. Well, in an atom, we have our core here, the middle, and this is called a nucleus. Our nucleus is made of protons and neutrons. We haven't discussed neutrons here yet, so I'll write it down. So a neutron is a neutrally charged particle. That means it has no charge. It's not positive and it's not negative. So we'll write that it's made of protons and neutrons. So in sodium, we have 12 neutrons. And if you're curious and you want to go ahead and get ahead of the series, we can go ahead and tell you real fast that your atomic number minus your atomic mass minus your atomic number equals the number of neutrons. And you would round that to a whole number because you don't have just part of a neutron. There's more to go into that. It has to do with averaging. That's why you don't have whole numbers as your atomic mass. We take different isotopes of elements, and that's why our atomic masses are different on the periodic table. So anyways, that's going to be in a future video. It's a little advanced for the scope of this exercise, so let's go ahead and continue with what we have. So in our nucleus, we have our protons and our neutrons. So that means we have 11 protons, which are going to be our positively charged particles, and we'll denote them with a little circle with the plus in them. And then we have neutrons, and those are going to be denoted by just a circle with nothing in them. And we'll go ahead and continue to draw this until we have all 11 of our protons and 12 of our neutrons in our nucleus here. So now that we have all of our protons and neutrons drawn, this part right here, this entire group of protons and neutrons is called our nucleus. That's what's at the middle of an atom. So now that we have our nucleus, we need to figure out a way to make this charge 0, right? Because right now its charge is 11, since 11 positively charged particles plus 12 neutrally charged particles yields a positive 11 charge. So that means we need to draw 11 electrons. So drawing electrons is a little complicated. There are other resources that I will provide in future videos. I'll likely do it with the periodic table video just because That way I can also discuss our electron configuration, since that's really complicated chemistry in my opinion, and it's not something you really need to concern yourself with now. So I'll just tell you something simple. So to begin with, we can say that the first shell, right? So a shell is basically a ring that our electrons are going to flow in. So these are our electrons, and they kind of orbit our nucleus, sort of like planets, if you will. And we'll draw a little negative sign inside these circles, so that way we know that those are our electrons. So now we have 2 electrons, and that's as much as the first shell can hold. It can't hold more than 2. But our next shell, which is going to be the next orbit, so maybe like another planet in orbit around our sun, which would be our nucleus, here we can actually hold 8, which would bring us to 11 electrons, right? So we'll go ahead and draw those here. So that's 4, 5, 6, 7, 8. And that's how many our second shell can hold. It can't hold more than 8. It can always hold less than 8, sure, but it can't hold more. Now, our outer shell, which is the last one for this atom, there can be more. There can be more than just 3 shells per atom. But for the sake of sodium, there's only 3. And in our last shell, we have just 1 electron. So let's look. We have 1, 2, 3 shells. And in our first shell, we have 2 electrons. So we'll write 2 here. And in our second shell, we have 8. And in our last shell, we have 1. So 8 plus 2 is 10, plus 1 is 11. So if we were to ignore our nucleus and just focus on the shells we have, then we can say that the charge for the shells is negative 11. And if we look at our nucleus, we can count the number of protons. And we could ignore the neutrons for now, since they're not significant to figuring out the charge of your atom. And we can go ahead and add 11. And we'll see that positive 11 plus negative 11 is 0. So that means that the charge on sodium should be 0. So why did I tell you to do this? The reason I told you to do this math right here, just this simple addition, is to confirm that you drew it properly, because it's really easy when you're drawing these individual circles to lose track or to make a mistake. So that's why I tell you to do the math. It helps to kind of confirm that you've done everything properly. So now that we understand what our atoms are made out of, let's discuss why they're significant. So our electrons are basically what allow our atoms to actually react. So whenever we have 2 different atoms, let's say sodium and chlorine, right? So our sodium, let's just focus on the outer shell, because these ones are what's called stable, right? They're completely full. But this one is not. This one has 1 extra electron. So our sodium has an extra electron in the outer shell. And I'm not going to draw chlorine. I'll just kind of explain that chlorine needs 1 more in its outer shell. So it wants an extra electron, right? So if chlorine wants an extra electron and sodium has 1, then these 2 are going to react pretty easily. And that's why we have sodium chloride, which is table salt. So this little electron kind of goes away and goes to chlorine, and then chlorine accepts it, and now these 2 are bonded. So that's why it's significant to pay attention to your outer shell. This tells you how reactive something is going to be. If you need just 1, or you want to donate just 1 electron, then you're the most reactive out of all of them. But let's say that we didn't have this electron out here, and we just had this solid full shell of 8 electrons. This is extremely stable. It doesn't want anything, and it doesn't want to give anything away. So it's not really going to be very reactive. And that's why we have what's called our noble gases. All of this is a little out of the scope of what an atom is made out of. But it is important to understand, since we are going to be covering this in a periodic table video. we have what's called noble gases and actinide series, and all of that is important to how the atoms behave and how the elements will react with each other. A good example, I guess, is sodium and lithium, which in the periodic table are kind of right above and underneath each other. So lithium would be here on the periodic table, and sodium would be right here. So lithium and sodium aren't going to react with each other, but since they are right above and below each other, they will behave very similarly with other elements. So lithium, for example, can actually react with chlorine very much in the same way that sodium does. And I think that's about as far as I'll get into the future videos. So I will go ahead and save all the rest of the periodic table talk for future videos. And with that, I think we can go ahead and conclude this video on the parts of an atom. And we'll go into more depth in future videos, and maybe we'll even talk about theories and, physical chemistry, stuff like that. A lot of chemists actually don't like physical chemistry because, in my opinion, it's actually really difficult. It goes into a lot of theory, and it's a lot of things that you can't see and you personally can't test without millions of dollars worth of machinery and equipment. So while that might seem a little daunting, that's why I'm going into it very slowly and giving you bits and pieces of it as we go in our videos. So with that, I think we'll go ahead and conclude this video. Thank you for tuning in. And as always, we do have the Discord. If you have any questions, you can go ahead and visit us there and we'll answer them as soon as we're able to. Thank you for tuning in.